In this exercise, we're going to explore the use of joins in SQL. Joins allow us to compare two data sets in different ways. In relational databases, tables represent sets of data. For example, we've already looked at the album table. This table is a set that contains a list of all albums in our database. Similar, the tracks table is just a data set of songs that are on albums. When we compare the two, we're doing a SQL join. The slide that we're reviewing depicts 7 different types of joins. Before we look at these different types, it's necessary to understand why we do joins. Each table in a relational database is designed to contain a specific type of data. Let's go back again and look at our albums and track table to understand this. The album table contains a list of all albums and the artist or group who released that album. It does not contain all the songs on that album. To find that list, we need to look at the tracks table, which now contains the name of all the songs and the album ID, composer, as well as other information. So let's ask the question here. What if I want to know the name of a song and the artist who sang it? This is a join, taking information that's contained on 2 or more tables, combining them to retrieve or find all data elements that we need. The join we just described is the one found in the center of our chart. This is known as an inner join, or the intersection of 2 data sets. There are other types of joins that we should be familiar with. Left joins show all data from set A even if no data is found in set B. Right joins show all data from set B even if no data is found in set A. There are also other varieties of right and left joins. In these varieties, we're going to show all information in A that's not contained in B, or all information from B that's not contained in A. On the lower section of our chart, we're showing full outer joins. And again, there are 2 varieties of this. The first full outer join is to show all information from both data sets, regardless of whether it appears in the other data set or not. And the other variety is where we show all information except that that's contained in both data sets. Let's now look at how we create these joins in SQL. Our first join is using the artist table and the album table. We are answering the question, show me all artists that have listed albums in our database. There are a few things to point out about this query. First, we have included the list of fields that I want to see. I have also aliased or named each field using 2 different syntaxes. Both syntaxes work correctly. The from clause tells SQL where to retrieve the information from. The on clause tells SQL how the tables relate to each other. Executing the command, the result set shows us each artist and the albums that they have recorded. The next SQL statement is just an alternative syntax for the same query. MySQL will interpret both of these the same way. Notice in this SQL statement that the join is implied and not explicitly shown. Moving forward in this course, I will demonstrate both syntaxes interchangeably. The next SQL command answers a slightly different question. Give me all artists in our database and the name of the albums they recorded. This is a left join. We call it a left join because it shows all record in the artists table and then any associated records in the albums table. The last example of a join that I'm going to show you is commonly referred to as a cross product. Instead of asking you the business question right now, I want you to take this away and think about this as this course unfolds. Where would I use, or why would I use, a cross product? But in essence, a cross product takes each and every record from the artist's table and matches it against every album in the albums table. So the number of records that we'll get will be the cross product of both tables. Consider this as we go forward where you might use this type of join. We haven't gone over each and every type of join that you're likely to see, but what we have given you are the most common varieties that you're likely to use, and those that will give you a good basis for the remainder of this course. We'll continue to use joins with each exercise that we go through.